The Manhattan Project was a successful research and development program during World War II aimed at producing the first nuclear weapons. Two types of atomic bombs were developed. A uranium gun-type bomb, exemplified by Little Boy, dropped on Hiroshima on August 6, 1945, and a plutonium implosion-type bomb, exemplified by Fat Man, dropped on Nagasaki on August 9, 1945. Plutonium was handled by chemists, technicians, and physicists involved in the Manhattan Project, but at the time, the effects of plutonium on the human body were largely unknown. Contamination of project facilities became a significant concern. Plutonium-238 and plutonium-239 are alpha particle emitters, making them extremely difficult to detect inside the body. The easiest way to detect plutonium while a person is still alive is by analyzing urine and feces. This method has its limits, because only a small fraction of plutonium is excreted. In 1944, Dr. Robert Stone, the health director at the Met Lab, was urged by lead chemist Glenn Seaborg, a Nobel Prize winner who discovered plutonium, to develop a safety program. Tracer experiments on animals began in 1944, and in April 1945, human experiments were approved. The first took place on April 10th at the Manhattan Project Army Hospital in Oak Ridge, followed by tests in Chicago and San Francisco. Albert Stevens was selected for the California test and designated Cal-1 in official documents. Albert Stevens, a house painter born in 1887 in Ohio, moved to California in the 1920s with his wife. In 1945, he was misdiagnosed with terminal cancer after checking into the University of California Hospital in San Francisco with a gastric ulcer. Dr. Earl Miller, the acting chief of radiology, saw him as a suitable candidate for the experiment due to his presumed fatal condition. Stevens was informed of his fatal diagnosis and offered an experimental treatment.
But the Department of Defense was very interested in the effects of total body irradiation. Because if there's a nuclear war and people get irradiated, are they going to be able to function? Will a pilot who's flying a plane be able to land the plane? Will they be able to fight will they be able to work? Ironically, the people they wanted to do this experiment on were precisely the people who were least likely to derive any benefit from it. We knew that certain kinds of cancer were sensitive to radiation. So irradiating those patients might expect to help them. But then the side effects of the radiation will be the side effects of the cancer, and the Department of Defense wasn't particularly interested in the effects of radiation on people with metastatic cancer. They wanted to know what the effects of radiation were on a healthy 23-year-old pilot. And that could be best studied by irradiating people whose cancers were not going to respond to the radiation.
As part of the experiment, Stevens was injected with approximately 131 kilobecquerel of plutonium-238 and plutonium-239. Doctors and researchers had no clear understanding of how such a high dose of radioactive material would affect the human body. Surprisingly, Stevens showed no immediate health problems and did not develop cancer. The misdiagnosis was discovered during surgery, when surgeons found an inflamed but non-cancerous stomach ulcer which they removed. Stevens was stitched up, treated and sent home under the belief that his cancer was under control. Only a select few knew the truth about what was in Stevens' body. Neither the surgeons nor the nurses were aware of the plutonium, and Stevens himself had no idea. Stevens' son, Thomas, later recounted how samples were regularly collected from a shed behind their house by a nurse. The original data from Stevens' stool and urine samples were collected for 340 days post-injection and analyzed by Kenneth Scott, who never disclosed the true reason for the testing. Stevens' sister, a nurse, found it odd that all of his medical care was free, but accepted the explanation that he was undergoing experimental treatment. Stevens would return to the hospital for free gastrointestinal lab work whenever he experienced health issues. Around 10 years after the injection, a radiologist noted significant degeneration in Stevens' lumbar spine attributed to plutonium's tendency to accumulate in bones. On January 9, 1966, Stevens died of cardiorespiratory failure at age 79. His cremated remains were sent to the Aragon National Laboratory Center for Human Radiobiology in 1975 and were never returned to the chapel where they were originally held. Stevens received an estimated 6,400 rem of radiation over 20 years, about 300 rem annually. The annual whole-body dose permitted for radiation workers in the US is 5 rem. Stevens' total dose was roughly 60 times that limit, making him one of the most radioactive humans ever recorded. The case of Albert Stevens significantly contributed to understanding how plutonium behaves in the human body. Many experts said it was a miracle he survived the experiment. Most of the other patients undergoing the experiment died shortly after injection due to their terminal illnesses. Stevens' case is now seen as one of the most extreme examples of medical ethics violation in the 20th century, as he was exposed to potentially lethal radiation without his knowledge or consent. In the 1980s, investigative journalist Eileen Wilson exposed these experiments in her research on post-war radiation tests. Her work led to compensation for Stevens' descendants and regulatory changes for medical experiments, which were endorsed by President Bill Clinton in 1995. If you enjoyed this video, please make sure to like and subscribe.